Welcome back. I was told that the proctor was late for the exam, and I truly apologize for that. On the bright side, the field trip went well, I think. Guess I'll find out next class period when we review it with the students. We're starting our last content material, talking about astronomy. So when I say astronomy, what do you think about? What are your expectations for stars. What we'll be talking about? Okay, stars.
We're going to make a model of the solar system using clay.
We're not going to do that.
Yeah.
What else? Telescopes. We're not going to make them, but telescopes involved.
Go to the lake at night and look at the stars.
Oh, and that's
look at stars.
Yeah.
Okay, observing.
Constellations.
Horoscopes.
Not so much.
Astrology.
So let's start with the difference between astronomy and astrology, because understanding this is an important thing for teachers to be able to pass on to their students in grade school and high school. So astronomy is studying the stars. Astro comes from the root aster, which means star. Hence, an asterisk literally is a star, right? So astronomy is the science of studying the stars. And involved in astronomy, we have their positions, what makes them what they are, and just a wealth of things. Astrology still has the astro part. Still is dealing with stars. Astrology is taking the positions of the stars in the sky and interpreting that to say how your life is going to progress. Now, the difference in the two, well, there's similarities and there's differences. The difference is astronomy, the knowledge we have and our understanding is built by the scientific method. Now, we have to remember that scientific method for the final exam, so let's review it again. You guys did great when we did that initially.
Make an observable something.
Okay, so we observe something interesting. That curiosity is key to science. If you're not interested in why things happen, science is definitely not the field for you. So you observe something interesting, and then what's the next step after you observe something interesting?
Create a hypothesis that has testable
predictions. You create a hypothesis that makes testable predictions that's based on scientific information and explains why the observation occurs. And so everything we have in astronomy is built on that process. Astrology isn't. And so it's not a science because it's not built on that process. To be a science, it has to be built on that scientific process. Oh, I skipped the step on testing. And really important because a lot of people get confused on this. After you do the test, you have two options. Either your prediction turned out to be correct and you go and you do a different test of a prediction, or your prediction turned out to be incorrect and you modify the hypothesis. I should complete that while we're on scientific method. Astronomy says based on the position of the sun in the sky, so we have stars and we have constellations, and the sun goes through constellations as the earth orbits the sun. Notice I said the sun goes through them. When we look at the sun from the earth, it looks like it's in a constellation. The fact is our point of view is changing. It's kind of like if I stand here, I say, okay, Hannah is in front of the middle hole in the cabinets. But then if I come over here, Hannah has moved. Hannah's now in front of Bryson. Now Hannah didn't really move, I moved. But when we're talking about the position of the sun, we're talking about where it appears to us. So they say where the sun is going to affect our lives. But there's no connection. There's no scientific connection between those. And the lack of the scientific connection is why it's not a science. It's called a pseudoscience because it pretends to be a science, but it's not. And hence, we don't teach astrology in a scientific classroom because it's not based on scientific method. For the same reason that we don't teach religion in a scientific classroom, because it's not based on the scientific method. I believe quite strongly in my Christian faith. So just because we don't teach it in a scientific classroom doesn't mean it's not true or that we don't believe it. It's just a different thing. Now, with that in mind, I don't believe that astrology is true. I don't believe that the position of the sun on the day I was born and the position of the sun today is going to affect my life.
So astrology is like Virgo, Sagittarius, all that stuff.
Yes, astrology is when the sun is in this constellation, and you were born when the sun was in this constellation, and that's how you define things in your life. And it's kind of humorous. The calendars. Let's just do some quick astronomy things that you probably never thought about. How many days are there in a year?
365 days.
365. Why are there 365 days in a year?
That's how long it takes for one orbit. One orbit.
Okay, that's how long it takes for the Earth to make one orbit around the sun. Almost.
Well, leap year.
So we have leap years. The leap year system was in the calendar back in the Julian calendar, the calendar of Julius Caesar. And so how often do we have leap years?
4 years.
I thought you said 3.
I said 4.
Okay, every 4 years we have a leap day that we add, February 29. And so that makes the average year is 365 plus 1 every 4, so you add another quarter, 365.25 years. Because it takes a little bit longer than 1 year for us to orbit the sun. Or excuse me, a little bit longer than 365 days for us to orbit the sun. Now, to the best of our reckoning, the actual time it takes for us to orbit the sun is 365.2422 days. So 365.25, that's a little bit longer than the time that it takes for us to orbit the sun. So the Gregorian calendar is our current calendar. Pope Gregory, there's probably some suffix after him, was the one who commissioned this calendar. And this calendar has an omission. Right, we have 365.25, it needs to be 365.2422. And so every 100 years, we drop a leap day.
Wait, what?
Every 100 years. So every year that's divisible by 100, there is no leap day.
Wait,
So
I thought it was still every 4 years.
So then 2000.
that's an exception.
2000 didn't have a leap day.
It did! Because there's one more exception.
So yes!
There's one more exception because that correction would have made it 365 it's 365 plus a quarter minus 1/100. That would have been 365.24.
We are not taking
No, it's not
trigonometry.
I thought it was just every 4 years.
No, it's not. In your lifetime it will be, but it's not.
In our lifetime, what would be?
You'll have a leap day every 4 years. But with skipping leap day every 100 years, then that makes the average year 365.24 days long, which once again is too short. And so they add a leap day back in every 400 years. And so that's going to add 0.025,
Is
0.0025.
the day on Earth like the actual amount of time? Is that an irrational number? Is that why we keep changing it?
Well, is it irrational? That's actually incorrect, but it's not fixed is the real problem. It varies somewhat.
Okay.
So the system we have has 3 rules. Every year that's divisible by 4, you add a leap day. But every year that's divisible by 100, you subtract the leap day back out. But every year that's divisible by 400, you add it back in. And so since 2000 was divisible by 400, it was added back in. So in my lifetime, I will never experience a skipped leap day. If you guys live until the year 2100, then you'll have a skipped leap day. And you were probably born like in 2000 or maybe.
No, I was born in 2000.
She is the only one. The rest of us are old.
And I'm young.
Okay, so the rest of you lived through
102
a
years
year
old.
that had all three of them come up, right? Add it, skip it, add it back in.
No.
Wait, what year are you talking about?
2000.
Oh yeah.
Oh,
All
yeah,
those things.
technically, yeah.
And then you have to live to be over 100 to get to another one. And that one's not going to have the third one. It's going to just add it, take it back out.
I would just slap you with my kid. No, I was kidding.
Hey, it's a good chance. My grandma lived to be 105. She died a year ago. Year ago? Yeah. I think, yeah. Okay, so got kind of off on that very important astronomy concept. But we're studying the stars, and the sun definitely affects our lives. So if you say the stars don't affect your life, you're kind of missing something because the sun is a star. So when we do astronomy, what kinds of things can we directly interact with?
I'm just kidding.
That is
The
what.
sunlight.
Okay, sunlight definitely, but what can we send satellites to, or what have we sent satellites to? I say satellites. Let's go with rockets.
You mean planets.
Mars. Okay,
The moon.
the moon. What else?
Just the outer space in general.
We
Really far
sent them
I just
to
said that, but it wasn't
dwarf planets.
specified enough.
To dwarf planets, we did send.
Like,
We sent New Horizons. It's been a few years now. It flew past Pluto, which is a dwarf planet, and helped us to understand it much, much better than we did before. And now it's on its way to go visit other dwarf planets. Well, other dwarf planets. I think the things it's identified.
Wait, is it going out of our solar system?
New Horizons, no. Voyager, yes. I forgot which. There are two Voyager spacecraft, and one of them is at what they call the heliopods, the place where the solar winds, the stuff that the sun is constantly blowing off, suddenly disappear. And so they consider that as a boundary for the solar system, so which reached the boundary of the solar system. So we have sent spacecraft to explore various things within our solar system, not everything, but we had example of dwarf planets, moon. We've also sent spacecraft to land on asteroids. So we've done a lot of direct exploration. And we take what we know from Earth. We just finished geology. We learned about things like plate tectonics and erosion and weathering and all these things. And we take that knowledge and we apply them to the other planets. We call that comparative planetology. So the things we've learned on Earth here about the planets, we're going to apply it to other planets to help us interpret what we see. Right? That is the scientific method. We're taking previous knowledge and using that to help us understand new things. And then we have the sun. Yes, we have sent spacecraft, quote, to the sun. We haven't sent spacecraft to, quote, land on the sun. Don't get me confused here. But we sent them to collect stuff to tell us more about the atmosphere of the sun than what we can see just from light. And so we use our knowledge of the sun to help us interpret other stars. Now, one of the things that's kind of funny is we really don't know that much about other stars because all we can see is the light that comes from them. That's all we really have to study stars other than the sun. And some astronomers have said, our own sun, we'd understand it so much better if it just wasn't so close to us. It's a tongue-in-cheek joke. Because it's close to us, we can find that a lot of our ideas are wrong. Whereas with stars that are far away, we don't have ways to probe and know that we're wrong. And so people come up with theories because they're not getting disproven, whereas with the sun, you can be disproven a lot. So we're going to be looking at first the solar system, and then going outward because we use the solar system to help us interpret everything else. 15-minute introduction, yeah.
I heard that when you look at a lot of this, well, really all the stars, you're actually looking in the past. That's what you're seeing.
That's correct. It takes, light takes time to travel. My voice takes time to travel. When you hear me say stuff, you're not hearing it live. You're hearing it delayed. By how much? Sound travels at around 340 meters a second. We're separated by about, well, let's say 3.4 meters. So if you take 340 meters, well, 3.4 meters divided by 340 meters per second, you're about, if I do my math right, about 0.01 seconds delayed. So everything you're hearing is delayed by just a small amount. Well, light goes a lot faster. Light travels 300 million meters a second. And so you're seeing me delayed, but you're seeing me delayed by something that's in the millionths of a second. So, I mean, who could ever determine that? But if you're looking at something farther away, like even the sun, it takes minutes for the light to go from the sun to us. So when we look at the sun, we're seeing how it was a few minutes ago. And if we look at something farther away, like, Jupiter. Jupiter is farther away from us than the sun, and so we're seeing Jupiter farther in the past. Not very far in the past, but farther in the past. Then if you look at something distant, like recently you saw maybe pictures of the first image of a black hole. Well, M87 is, I forgot the number, but I believe it was millions of light years away. That means its distance is going to take light millions of years to travel. So we're seeing how it was at the time the light was emitted millions of years ago.
Imagine if we put a mirror over there and look back on what Earth was like that long ago.
There are ideas of trying to do that. If the universe had the right geometry, we could do that if we had a strong enough telescope. And I've seen, I just recently watched a movie where that was the premise, that they built the telescope so strong that they could see in the past. But it was really ridiculous. They could see people inside buildings in the past.
Have you seen the movie Interstellar with Matthew McConaughey?
Sadly, yeah.
Well, does that relate to like seeing in the past and all the stuff that we're kind of talking about?
The movie has some serious flaws in it. In theory, you could go potentially back in time, but you can never interact with something that is from before the time you came from. So that right there is a flaw. And that theory is kind of, let's say, not something anyone actually believes.
The going back in time theory?
Yeah.
I thought people did believe that. About the black holes and stuff. That you go back in time if you go into a black hole or something. You could figure out how to do it without getting crushed.
Yeah, figure out how to do it without getting crushed is a good thing.
My science teacher said in integrated freshman year in high school.
So with black holes, and black holes are a serious astronomy topic. When you get closer to a black hole, you have what we call relativity starting to make changes to how things operate. And what happens is the rate at which time passes for you is different than the rate at which time passes for me. So if I were observing you through a telescope as you approach the event horizon of M87, the event horizon is the point that's the last visible port stuff before you get to the black hole, right? That's why I put little air quotes around picture of a black hole. You can't see a black hole. That's the definition of a black hole. But you can see around it, and that's what their picture is.
Is this considering that you can see her at actual time?
It doesn't really matter, but yeah, sure. What I would observe, right? So, in reality, it was 5 billion years ago that she fell in, and I'm watching her because I'm seeing the light now. But I would see you aging very, 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 very slowly. So, like in the movie The Martian, he's on a planet that is very massive, and he hasn't aged very much because it's real. He will age at a different rate than we do. And as you're going in, you would age at a different rate than I do. So I would watch you and I would say, wow, I've been watching her for 50 years and she's like 1 day older.
So is that why he doesn't grow old, but his daughter does?
Yes.
Wait, so he is growing old, but the light looks different or something?
what happens is the person who is away is going to have a different rate at which time passes than the person here. And so you have a variable aging. And so I would see you never actually get into that black hole. Time would essentially stop for you and you'd never get in. Whereas you would see your time just runs normal and you go in and so on. Yes. Well, that's why we need magic. So it just happens in the movie, TV show Sliders and in all of these things with black holes.
So some people think it's like an alternate, like almost like an alternate universe kind of thing.
I have my own crazy theory on that. But yeah. We're not going to go to my own crazy theory today.
Crazy theory.
Are you gonna lecture during lab if we keep asking questions?
I want to hear the crazy theory now.
It is legitimate stuff. Okay, so black holes. Black holes, what we know about black holes is things can enter, things cannot exit. Because they have so much mass in such a small area that the energy that the speed something would have to travel at to escape is faster than the speed of light. So nothing can come out. But things can come in, and as things come in, the energy increases. We have lots of black holes, and we have lots of clumping that scales. We have like a planetary system. Smaller than planetary system, we have planets. Planetary system means planets orbiting the sun. We have planets with moons orbiting them. It's the same fundamental thing, just a bigger size. And we go bigger and we have globular clusters. And globular clusters are stars that are orbiting sometimes a black hole, sometimes just their center of mass. You go bigger and you have galaxies. You go bigger and you have clusters of galaxies. Well, my wacky theory is, based on what we know about our universe, science says that we only know about, I think I said this, right? What percentage of the matter in our universe do we know anything about?
0.0000.
Actually, 4. It's better than that. Everything we know about in life, according to their basic understanding, is 4% of what really exists. 96% of all of the matter in space, in the universe, we have no knowledge about. That is, we don't even know what it is or where it is. We can calculate something. And so we have two things called dark energy and dark matter. Dark energy is causing things in the universe to move faster. It's adding energy to the universe. And dark matter is causing gravitational attraction. We don't know what's causing these, so we call them dark. So my theory is that maybe we're living inside of a black hole. And so stuff comes in, that would be the dark energy stuff coming in, and it would help us to explain the dark energy. And that's my own loony theory. I have read after I came up with articles suggesting that maybe we are in the event horizon of a black hole. So I'm not the only one that has this crazy theory.
And in that case, we could never leave because we have to go super fast.
Right, we couldn't get out. Now, the solar system, the things it has, we've talked about the sun. The sun is an example of a star. What's the name of the sun? There's a couple.
The center of our solar system.
That's not one of them.
SUN.
Okay, we can call it sun. That's a name for it. Yeah. What system do we live in?
The Milky Way. Is it the Milky Way?
That's our galaxy.
The solar system.
We live in the solar system because one name for the sun is Sol. So the solar system is the system of Sol.
But aren't all suns Sol?
No. Another name for our sun is Helios. So we have a few names for the sun, just like we have a few names for the moon. What are some names for the moon?
Lunar.
Okay, Luna.
Or something. Oh, yeah.
Luna is the common one I know besides moon.
You just added it on.
Well, yeah, it's fine.
And that's only our moon, so it's not other moons.
Right, that's only our moon.
What defines a moon? Because
Yeah, what's this?
Okay, what defines a moon? Very good question for this lecture. A moon is an object that orbits a planet. Okay? So the moon, Luna, is not our only moon. We have other artificial moons, things like the satellites that we sent up. Those would also be moons, they're just not natural moons. And right now we have a second temporary moon.
So
There is an asteroid that is orbiting about us for a while, and then it's going to take off again. So right now we have, I think, 2 natural moons
So,
that are
asteroids and
recognized.
comets would comets
Mhm.
comets would count as moons if they're orbiting a planet.
Yes,
anything will
indeed. Mars has 2 moons. The 2 moons of Mars are Phobos
Asteroid
and
comet.
Deimos. No, Phobos and Deimos. They are gods of fear and terror. And both of them are believed to have been captured asteroids. So they were asteroids, but then they were captured by Mars, and they changed names to moons. And if you go to something like Jupiter has, I don't know, over 60, probably over 70 known moons. Almost all of those moons, I say almost all, it has 4 major moons that aren't asteroids. All the rest are captured asteroids.
Would we be able to stand on Jupiter?
No. Okay, so we're talking about planets now, and I'm going to talk about planets more, but Jupiter, every, quote, Jovian planet, which are planets like Jupiter, is a gas planet. So you can't stand on it. If you were to fall into it, and we have sent probes into the atmosphere of Jupiter and I believe Saturn, you just have an atmosphere that gets denser and denser and denser until at some point you would say this is a liquid, but you never even splash. You never have going from air to liquid or gas to liquid. It just got thicker.
But would there be solid?
Eventually there is a solid. There's a rock at the center of Jupiter that's bigger than the Earth. So all of the planets have big rocks at their core. It's just the ones that are Jupiter and beyond also have a lot of gas. And we'll talk about why they have a lot of gas. Okay, so asteroids, most of the asteroids fall between the orbits of Mars and Jupiter. That's where the asteroid belt is. If you were to watch things like Star Wars, you would think that flying through an asteroid belt is really hairy because you've got all these asteroids everywhere you have to avoid. The asteroid belt is almost completely empty space. It would be very hard to hit an asteroid probably because it's mostly empty. But it is a belt. There's a lot of rocks out there nonetheless. And the origin of those rocks is actually something that's debated. Some people think that maybe it was something that was growing to be a planet that got destroyed. Like it was torn up by a collision or by gravity with Jupiter. But asteroids are basically rocks. Comets are essentially ice balls, but they also have rock. So comets and asteroids are fundamentally different, right? Just rock for the asteroid, a lot of ice, along with a little rock for the comets. The comets, we see, 1 or 2 comets a year probably, but they're not really that special of an object. What they are is beyond the orbit of the planets, that because of gravitational interactions, get their orbits screwed up, and they come flying in toward the sun. And when they get close to the sun, the heating of the sun causes them to give off gas, to sublimate, to convert directly from ice into gas. That's a word we've already learned. And they give off all that gas, and that's what we see as the tail of the comet.
So wait.
So it's a shooting
The
star.
comet gives off gas, and that's why it has a tail. That's
Mhm.
what you just said.
So let's move forward to slide 3. For the test, you will need to know the 8 planets in order from the sun out. So there they are.
Well, we have pictures. I'm just kidding.
You won't have pictures. And if you need a mnemonic, I was reading an astronomy group and somebody said, what's the best mnemonic for memorizing the planets in order? Somebody's response was, well, I memorized it this way. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. It's a simple mnemonic.
There's my very educated mother just served us.
My students decided, when Pluto got kicked out, my students decided that nachos was the best thing to finish that.
I thought it was nougat.
My students said nachos. I've gone with that because
I learned it very differently.
my astronomy class.
We
Well-
had a song.
Okay, there are different ways. Yeah.
Can I go back for a second? You
Yes.
said sublimation is the comet, the gas thing.
Sublimation is when it goes from ice to gas.
So wait, in this order is what you want it on the test?
Yes.
Is it gonna be like we write it out, or is it gonna be like which
how
one
is
is first? A, B, C, or D?
Yeah, that's what I was like
Educated.
confused about. How are we gonna know them in order if it's only multiple choice?
Serve us nacho.
And of course, you can have different variations, right? Nougat, fine. It's just something for you to remember it. But you do have to have them memorized in order.
But can you? Is it gonna be like what planet is first? A, B, C, or D?
You're going to write down Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
Okay.
So you won't have a list to organize or anything like that. You'll have to write down the 8 in order.
Why is it pronounced like that?
Which one?
Uranus?
There's 2 ways of pronouncing Uranus. There's Uranus and Uranus. Either one, as I understand, is considered correct. I use Uranus because it takes away a lot of the jokes, but somebody pointed out you can also make some off-color jokes with Uranus. So you really can't win. Too bad it's not called King George's star.
It all comes with maturity level.
When it was originally discovered, William Herschel wanted to name it Georgius Sidereus for King George's star, but it wasn't allowed because they have to be named after gods. King George wasn't a god.
Why does it be named after them?
Convention.
I totally just realized that they're named after gods.
It's okay, Amber.
Well, that's because
Obviously,
There's
your high
the
school
Earth
class
isn't
is
named
not
after
class.
I
What?
know the Greek
Earth
gods.
isn't named after a god.
I know. Is Terra not a god?
What?
Is Terra not a god?
Terra.
I think Terra's a god.
Earth, Terra?
Yes.
That's part of whatever that he or she, her, him or hers.
I don't know. I mean, that's terra firma from Earth. But anyway, I'm pretty sure Terra is named for the Earth. I didn't look it up or study it. It's just my impression. So the solar system, we want to talk about the formation of the solar system. And once again, I'm not here to contradict a firmly held religious belief. If you believe that God put the sun in the sky on the 4th day, and the moon and the stars also, that's fine. I'm not here to tell you that's not something to believe. No. Okay, days of creation. Day 1.
Amber,
And what's no, this is legit.
no one's back to
I
first
don't
grade
understand
now.
how God would have created the sun.
I was like,
Day 1,
5 minutes.
God created light.
Who's calling me that? I'm just kidding.
Day 1, God created light, and the evening and morning were the first day. So we have light and we have the day. What defines the day? You can quote a Doors song.
Wait, what?
When the sun comes up and comes down.
Okay, when the sun comes up and goes
So
down,
then when he formed a light, he didn't form the sun. He just
I disagree.
it's a questionable thing.
Wait,
It's
so what
something
do
that
you
takes an
believe?
explanation.
To people before you had a lot of astronomy, the sun was different from what they might consider stars.
Yeah.
Yep.
But you said you disagree.
Well, the sun is a star, but when Genesis says God created light, that might be the sun. And then when it says he created the stars, that could be like our planets, and then the stars and the things that look like little twinkles in the sky.
Okay, well, let's go through these days of creation real quick to try to settle some of the strong
Would
understandings.
these be on our test?
They could be, yeah.
Wait, is it creation?
Huh?
The days of
Well,
creation?
The days of creation that are appropriate for talking about astronomy. Yeah.
So can you make that very clear when ones are appropriate?
I am, yes.
That's
So,
what
So-
we need to know day one.
So
is
day
what?
one, he
Day
created light. And then on day two, he created firmament, separated the waters above from the waters below. Day three, he separated the waters of the land from the waters of the sea. He created fishes in the sea and grass in the land. Day four, he created the greater light to rule the day, the lesser light to rule the night, and the other stars
You are
also.
going so fast.
Amos,
It's in the Bible.
look in the Bible. Take it
I asked
out.
you
So-
to learn this in like Christian beliefs. I just don't remember anything.
So
about
day
this.
one is light, and day four
Is
the-
dark.
is the things that make light.
Okay, you
Oh.
said greater something and dark.
The greater light to rule the day. That's the sun. I mean, everybody believes that's the sun at the very least. And the lesser light to rule the night, we interpret that as the moon.
So we,
And then the stars also. So the sun, moon, and stars is the interpretation put to that. But then we have some questions, like every day, the evening and morning were the first day, the second day, the third day, the fourth day, the fifth day, the sixth day. How do we have the evening and morning? And how do we have light
24 hours.
before the sun?
Well,
a great
God
question.
has light.
Okay, so there's one answer. That's a legitimate answer that a lot of people say. That God came, and because God is light, that there was light. And so basically when it says the evening and the morning would be his entrance, the evening would be his exit. So he came, he did something, he left. That's one interpretation that's given to it. But the word that is used, according to my scholar friends who actually understand Hebrew, is yom, and yom is only used to designate a 24-hour period day. And so that's not saying it's not the correct interpretation, but it doesn't seem as strong when you look at the definition that was used. So my own personal belief, because you asked me what my belief is, you did,
I did.
is that the first day when he created light, I think what we have is somebody is envisioned seeing a movie. Everything's dark, and then the sky clears and they see light. But the sky wasn't so clear that they could see what was causing the light. That's my belief. Right? Because the creation story starts with the earth was void and without form, and there was water over the deeps. The Spirit moved over the surface of the waters. Or water over the, I may have said that wrong.
And that's suggesting that the earth was here, it just didn't look like it.
Right. The God had created the earth at a previous time, not the time of the Genesis story. And my belief then says that he also created the sun at a previous time, not the time of the Genesis story. And so day one, he cleared the atmosphere enough that light could get through. Day two, he further cleared the atmosphere, separating water from earth and in the sky. The next day, he further cleared water. So the first 3 days were all moving water. And then on the fourth day, then he cleared the sky some more because he prepared things for this. And that's when you can now see the sun, the moon, and the stars. Right? I see it as I'm watching a movie and these things are happening and I'm trying to write down what's happening and I'm doing the best I can to describe what I'm seeing. So that's my interpretation. So my interpretation then says that the universe God created before the creation of this earth. And because of that belief then, I don't have a problem with old ages for the universe.
So what do you
That's
mean
why someone-
old age is like saying that the earth is million years old, or saying like
Yeah, I agree with that.
I have zero problem saying that the sun is like 10 billion years old and the universe is 13.8 billion years old.
The other thing is, when you trace back how old the Earth is, you're assuming, I don't know, we don't know how long Adam and Eve were in the Garden of Eden. So they could have been in there for, what, millions of years, right?
They could have been. I've heard, well, that's my belief. I've heard people say, no, you're misreading. So maybe I'm wrong.
well, like they never give a specific thing. Like in the story in the Bible, it seems like it's so short, like it's only happening in a week or whatever. But I feel like it's not.
They could have just picked up where he created Eve and then where they sent
Yeah.
like years later.
Yeah, I feel like they didn't like say, well, on this day they went and looked at elephants. On this day they went and looked at giraffes. On this day, like
It
there's a
does
lot
kind of make
missing.
sense though, because they didn't have children until after this, and you know.
Right. There's no children until after sin. And I think that's part of the reason people say, because God said to be fruitful and multiply, since they didn't have children before sin, then it must have come reasonably quickly, is an argument I've heard for it not being long. Who can say? It's hard for me to reconcile a young Earth creation with the science we know, but at the same time, I think, as I said, the dinosaur tissues that still have soft tissue makes me question maybe we're not getting our dating right for the Earth. Okay, let's get a few more things here about this the solar system.
Can you explain this slide?
Yes, I am. So the theory, the scientific theory for how the Earth came into existence is that the Earth and everything in the solar system all came into existence at the same time. We had a big cloud of gas. Nebula is the Latin word for cloud.
Nebula is the Latin word for cloud.
Yes. So we have this big cloud of gas, and then a shock wave hits it. What's a shock wave? A sonic boom is an example of a shock wave. Or a wake behind a boat is an example of a shock wave.
Wait, nebula is the Latin word for cloud.
Cloud, yes.
And then a shockwave is what?
Something like a sonic boom is a shock wave. It's a wave that carries high pressure with it.
Hedgehog?
Not sonic hedgehog. And when that shock wave hits this big cloud, it causes it to compress. And when things compress, of course, they get closer together. And when things are closer together, the force of gravity is stronger. And so the shock wave sets into motion things getting closer, having a stronger force. Gravity is always pulling things together. And so gravity then causes it to continue to collapse. And so this big cloud of gas starts collapsing. And probably we're not the only star system that was formed from this one big solar nebula. We probably have other sibling stars to the sun that were formed as well.
Are
And-
there more systems besides the solar system in the Milky Way?
Oh, yes. Yes, billions. So everything is collapsing down and gravity's taking over, and you have centers where you have higher mass and thus higher gravitation, and things clump up. And so the biggest clump of what became our solar system was the sun. Now, according to our understanding of the process, the universe would have been, over 90% by number of atoms, hydrogen. And the remaining around 8% by number of atoms, helium. And so almost everything that formed in the solar nebula, it was almost all hydrogen with a little helium. Almost all of that is what everything's formed of. So the sun is largely hydrogen with just small amounts of helium. Around should have been, except for one thing. The sun being the biggest mass in our region, it got really hot because of everything falling in and compressing. And so it made the region around the sun very hot. And if the temperature is high, well, you know that water doesn't exist above 100 degrees Celsius at 1 atmosphere, right? It evaporates. And so the same thing is going to be true for most things they're just going to be in a gas phase at these temperatures during the formation of the Earth. And so the Earth couldn't hold on to these things because they couldn't clump together. Gravity would bring them together, but they wouldn't stick together. Yeah.
So I have a question. Why is it kind of related to what you were just saying, like how the sun has a temperature and the stuff around it is so hot? Why is it that Venus is supposed to be hotter than Mercury if Mercury is closer to the sun?
I will actually talk about that.
You will?
But no, I will,
Oh.
yes, but not right now in the middle of the story.
Okay.
So we have things that were close enough to the sun where the temperature was really high. Only things with high melting temperatures could stick together. What are things with high melting temperatures? Silicates. That's why we have so much silicates. What else? Iron. And then there's a few other things, right? Magnesium. And so that's the primary stuff that the Earth is made of because that's the stuff that could stick together at those high temperatures. But if you go further away, you get to what's called the frost line. The frost line is the region where the temperatures were cold enough that you could have things like hydrogen, stick together hydrogens. Well, not necessarily hydrogen, but you could have molecules stick together and form clumps. And in that case, there's a lot more material you can hold on to. So those things were able to hold on to much more material and grow much more significantly. And then they have those in their atmosphere. So everything that's beyond the frost line has lots of hydrogen, lots of helium, because those were the primary things in the solar nebula, and they were able to hold on to small chunks, grow enough mass that they had enough gravity to hold on to the rest of it. Yes?
2 questions. So is that why there's a difference between the inner and outer?
Yes, that's why.
And then is that why Mercury and all them are smaller than Jupiter and Venus and Neptune?
Yes. Both of those are correct.
Just making sure I'm understanding.
Now, our solar system, all of the planets orbit in the same plane. As we're all going around the sun in the same direction, the same flat disk, which seems a little odd.
Really?
Yes, really.
So
The only violations of that, to any significant effect, are Mercury, which is tilted pretty much, doesn't go very much above or below the plane though, because it has a small orbit. And then if you were to count Pluto is tilted a reasonable amount.
but how much are we tilted?
Well, we use us as the reference, so we're tilted 0
But I thought
for our orbit. For our
Oh.
spin is tilted 23.5 degrees
Okay,
from our orbit.
because don't we get seasons from the tilt of the
From
Earth?
the tilt of the Earth with respect to its orbit.
So technically we're straight, like even.
Our orbit we consider the reference point of 0. And then we're tilted with respect to our orbit.
So the orbit is 0.
And all the rest of the planets are within 5 degrees except for Mercury. So that flatness is believed to have come because our universe would randomly have just an average of rotation. And if something's rotating, I'm actually afraid to do this because I hurt my knee just twirling last week in class. But if you're spinning around like this and you pull your hands in, what happens?
You go faster.
You go faster.
When you go to America.
So if we had this big nebula that's randomly rotating just a little bit, as stuff comes in, it's also going to go faster. We call this conservation of angular momentum. And so the rotation rate spins up, but as it spins faster, it's going to flatten out. Just like if you put clay on the turntable and let it spin, it flattens out. And so it's believed that's why we have a flat solar system. Now I say it's a flat solar system. The solar system looks kind of like this, with stuff out here in a sphere. This stuff out here we call the Oort cloud. And that's made of icy objects. We also have a belt out here that goes around in the plane that's called the Kuiper belt, made of icy objects. So that's our understanding of the beginning of the solar system. We're going to continue to study the solar system and then go out to study stars.
What about other planets? Are we just gonna
Exoplanets? I mean, we're going to study the planets in our solar system, if that's what you mean.
like other ones.
But yeah, we're not going to say exoplanets because what we know about exoplanets is pretty much limited to they exist. We have lots of them that we know exist, different masses and whatnot.